told Killian I'd be back. I wouldn't want to be a liar.
Greetings, dear viewer. So this is the first part of a new series that will pick through the manure pile of flat earthers.
Vince, apparently they prefer the word retard.
Eh? Oh, how very quaint.
Flatards think there is a global conspiracy to hide the shape of the Earth, a conspiracy that dates back to antiquity, yet is all due to NASA and the United Nations, organisations formed in 1958 and 1945 respectively. What these mental defectives have yet to do is explain why the shape of the Earth is so significant that such a concerted effort to hide its shape would be necessary, let alone why treating the Earth as a spheroid allows the rest of humanity to be far, far, far more productive than they are. The best they can come up with is hand-waving about trying to undermine faith in their magic sky wizard, who allegedly built a flat Earth inside a giant snow globe just so that his creations could scuttle around talking to the ceiling and praising his capriciousness. Basically, their argument boils down to, "But my holy book!" They can't even agree on whether their flat Earth has an edge. Some of them think it does to suit their view of living in a giant snow globe. Others think it just goes on forever. This alone gives us a valuable insight into the fast pace of flatard research, because all they had to do at some point was travel a few thousand kilometres and find out. It's not like the last few thousand years they think they've been around have lacked the technologies to enable them to do that. They've had access to the same tools for measuring distances, directions and positions as the rest of us, and yet their achievements are nil. Despite this, these vacant-minded gobshites think they can make pronouncements about reality without having explored it. So, now that we have set the scene of who we're dealing with, let's get cracking. Flatards think Earth looks like this, because they saw it on a flag. This and this are examples of an azimuthal equidistant projection, one of many ways of projecting a three-dimensional spheroidal surface onto a two-dimensional one. If you've ever tried flattening out an orange peel into a nice map of its former self, you'll have noticed the problem. Presenting a rounded 3D surface in 2D means that something has to give. In the case of an azimuthal equidistant projection, what stays intact? Lines of longitude radiate from the centre of this polar projection, so directions from the centre point will be represented correctly. In fact, the centre point is the only point on this projection where one can determine the direction and distance to any other point correctly. For other points, only distances along lines of longitude will be consistent with reality. Distances and directions between any other two points will be incorrect. Consequently, shapes and areas are also incorrect, and become increasingly distorted the further from the centre of the map they are. We'll come back to that. The azimuthal equidistant projection does have some practical applications, but for general navigation, the problems highlighted mean it's an absolute clusterfuck. Consequently, flatards parading this as their go-to map of the world gives some indication of just how little thought they've put into things, as well as revealing that they've never tried to use it. Due to their avoidance of doing anything more difficult than navel-gazing, flatards preemptively claim that anything that looks a bit tricky can't be done. For instance, they can't even find out how big their disk world is because the UN would stop them.
Of course!
It is claimed that they patrol the southern seas and stop anyone going too far and finding the edge of the world. What these oxygen-deprived mouth breathers have failed to consider are the logistical requirements of such an operation. So let's do the thinking for them. Let's get a ballpark figure on how many patrol boats they would need. The straight-line distance from the North Pole to the tip of South America is about 16,200 kilometres. Since flatards claim that distances on land are the same on their magic disk world as they are in reality, it's going to be 16,200 kilometres for them too. Let's have our patrols passing roughly halfway between Tierra del Fuego and the Krakow Peninsula, say 16,500 kilometres from the North Pole. This gives a circumference of roughly 103,700 kilometres of ocean to patrol continuously. place a boat, say, every 10 kilometres, so no flatard can sneak past under the horizon, and the UN needs around 10,000 patrol boats just to stop flatard explorers discovering the truth. Ignoring the high probability that no flatard has explored further than the edge of their trailer park, I for one look forward to them providing proof of the largest boat fleet in the world, comprised of craft capable of handling the worst of the Southern Ocean. I also look forward to them finding out where they were built, who by, how much for, identifying shipyards capable of churning out 10,000 such vessels, and finding out where all the boat builders and crew actually are, given that nobody has noticed any of this stuff going on. Then of course they can explain why no flatard undertook such an expedition before the UN created this alleged fleet to stop them. There is of course one key reason why nobody will ever find the missing boats and their missing crew, and that's because it's just another pathetic ad hoc excuse concocted by flat earthers to try and account for their bone idleness. That and the idea that the Earth is flat is bollocks. Noting that flatards claim that distances on land are the same on their fantasy world, they've failed to consider a simple and fundamental problem. Whilst you could just stick a landmass onto a polar grid without changing distances between its locations, you can't do so without changing their coordinates. The best you can hope for is to get one line of points matched up, but then the coordinates of everywhere else are wrong. It's inescapable. Consider, for instance, Australia. 30 degrees south of the equator on the eastern coast is the small town of Red Rock. Let's take this point here, 30 degrees south and 153 degrees 13 minutes east. At the same latitude on the west coast, just 6 kilometres south of the town of Lehman, let's take this point at 30 degrees south, 115 degrees east. The difference in longitude is 38 degrees and 13 minutes. If you were to set off from our point near Red Rock and drive west until you got to our point near Lehman, you would cover a distance over land between these 2 points of 3,687 kilometres. So what happens if we travel along the same 30 degrees south latitude line for 38 degrees and 13 minutes on the polar grid of the flat Earth? The 30 degrees south line is 13,322 kilometres from the geographic North Pole and must be on the flat Earth too, for reasons we saw earlier. We know the longitudinal and hence angular separation between our 2 points at this latitude, 38 degrees and 13 minutes, or 38.217 degrees. The length of an arc on a circle subtended by an angle alpha is alpha pi r over 180. When we crunch the numbers, we find that 2 points on the flat Earth surface, 30 degrees south of the equator, and separated by 38 degrees and 13 minutes, are 8,886 kilometres apart. This is 2.41 times greater than the real distance between our points near Red Rock and Lehman. But flatards say that distances on land are the same on their giant space pizza as in real life, in this case 3,687 kilometres. In that case, they must agree that the separation in longitude on the flat Earth must be considerably smaller than it is in real life. It's an inescapable feature of the geometry. If we make L 2.41 times smaller, we must make the angle alpha 2.41 times smaller, which means that on the flat Earth, the difference in longitude between our points near Red Rock and Lehman would be just 15.85 degrees. Reality, however, begs to differ. And that's a paradox that flatards can't resolve. These points are 3,687 kilometres apart, and their longitudes are separated by 38 degrees and 13 minutes. It is simply impossible for flatards to keep distances the same without giving glaring discrepancies in their own coordinate system. And it is impossible to keep the coordinates of locations the same without giving glaring discrepancies in distances and, consequently, the shapes of land masses. Particularly paranoid flatards needn't rely on GPS to check this. They can use the old-fashioned methods of establishing longitude and latitude, and find themselves wondering why reality disagrees with their stupid beliefs. For the rest of us, the reason is simple. They're geometrically illiterate buffoons, and this is bollocks. The claim that distances on land are the same in the flatard disk world would also obviously mean that distances over sea couldn't be. As with problems on land, the further south you go, the greater the discrepancies would become if you travel over the ocean in anything other than a north-south direction. This also screws up simple travel. Qantas fly direct from Sydney to Johannesburg in South Africa 6 days a week. It's a direct distance of 11,060 kilometres, with the flight taking around 13 hours and 20 minutes, at a speed of 830 kilometres an hour. As you might have expected, things on the flat Earth aren't quite so simple. Sydney Airport is 151.1772 degrees east. Johannesburg's OR Tambo Airport is 28.2461 degrees east. The difference in longitude is therefore 122.9311 degrees. Sydney Airport is 13,759 kilometres from the North Pole. OR Tambo Airport is 12,894 kilometres from the North Pole. Now that we have two sides of the triangle and the angle between them, we can use the law of cosines to calculate the straight line distance from Sydney to Johannesburg on the flat Earth. The distance d is equal to the root of a squared plus b squared minus 2ab cos c. When we crunch the numbers, we find that on the fantasy flat Earth, the distance is 23,419 kilometres. This is more than twice as far as it is in reality. For the Boeing 747-400s that Qantas use on this route, this poses something of a problem. With maximum payload, they have a maximum range of 13,438 kilometres, which means they would fall rather short of their intended destination, which somewhat defeats the purpose of a direct flight. Fear not though, the route taken by the Flattard Airways flight would pass over Papua New Guinea, China, the Himalayas, India, the Gulf of Oman, the Arabian Peninsula, the Gulf of Aden, the countries of East Africa, including a nice view of Lake Malawi, so could refuel along the way. There is, however, a lack of stopover options along the route. The Tibetan Plateau has a paucity of international airports. India's Indira Gandhi Airport is a bit too close to maximum range. Qantas don't fly there anyway. The next best option with a long enough runway might be Netaji Subhas Chandra Bose International. However, it's more than 1,000 kilometres off the most direct route on the flat Earth, and Qantas don't fly there either. So, if the Earth is flat, where do these flights go? Since no passengers who have flown direct between Sydney and Johannesburg have ever spotted China, the Himalayas, the Arabian Peninsula or Eastern Africa, let alone stopped at any of their bloody airports, we can be quite sure that this isn't the route taken. Also, as passengers on these flights do arrive in the scheduled 13.5 hours or so, Flattard Airways would have to fly at an average speed of 1,756 kilometres per hour, and faster with a refuelling stop, rather than the more sedate 830 we found earlier. The maximum speed for a 747-400 is 988 kilometres per hour. So, unless Flattards can demonstrate that a 747-400 can fly at nearly double its rated maximum speed, and do so without critical components like wings and tailplanes simply being ripped off, and tell us where all the extra fuel is stored, and explain the slight discrepancy in scenery on the flight, we can safely say that the idea that the Earth is flat is bollocks. There is an even simpler problem which is a consequence of using a polar coordinate system: long-distance navigation. Travelling north or south are the only ways to travel in a straight line if you maintain a constant heading. If you maintain, say, a westerly compass heading on a flat Earth, you will follow a curved path. It would be inevitable. Clearly though, following a curved path on a constant compass heading is no good for commercial aviation, as it would waste prodigious amounts of fuel. The way to use the lowest amount of fuel and maximise your profit is obviously to travel as close to a straight line path as you can. Two problems would manifest themselves were Flattards to try it. The first is one we've already seen. On the flat Earth, the straight line routes takes you over a completely different path and completely different sites. This ties in with our earlier point about maintaining coordinates of locations. The second is with the compass. If you take the straight line path between two distant points on a flat Earth, your compass bearing would drift over time even if you kept the aircraft in level flight. For instance, start flying west and keep the plane in straight flight, and on the flat Earth your compass is going to drift south of that. Since flatards seem to think that with a round Earth you have to constantly point down to stop aircraft flying off into space, and conclude that Earth must be flat because they can't feel the plane flying down, they should, by the same pathetic reasoning, expect a plane flying west to be constantly banking to the right to maintain a westerly course. And remember, the further north the aircraft is, the more pronounced that bank is going to have to be, because the tighter the arc is going to be. And yet, not even flatards in North America and Canada have noticed this taking place and waved it around gleefully as proof of their codswallop. If flatards had passports and brains, they would have noticed that none of these effects happen, and never will, because this is bollocks. We're only just getting started, and we've already found some simple problems that are mathematically and geometrically irreconcilable between two differently shaped objects. We've seen that flatards can't even wrap their heads around the effects of their idiocy in 2 dimensions, so it's perhaps not surprising that their failures become even more laughable when dealing with 3. In the next part we'll continue looking at how geometrically illiterate flatards are, as we turn our attention skyward and see what subtractions from the sum of human knowledge they've been able to offer there. See you then.